Adventures of Math Girl. With the help of Pocket Ronnie, you also can become a trusty sidekick of Math Girl, like Kid Calculus and the Daring Derivative. Okay, we're doing 19C, and they're calling it 6 through 8, and I don't have the whole problem written up here, but basically it says Arnold bought some walkie-talkies for his parents for their anniversary, and then it says that they tried the walkie-talkies out right away to test their range, and it says the parents, they walked in opposite directions until they were 4,000 yards apart. Okay, so right now I know there's 3 scenarios for this lesson. So the parents walked in opposite directions. So I am looking at the scenario, what I labeled A. Doesn't matter what I labeled it, but the parents started at the same point and then they walked in opposite directions. Okay, so then the parents' names are Amos and Eunice. So it doesn't matter what I label these. I could label this as, this is the distance of Amos, dA. This is the distance of Eunice. Okay, so, but I do know, I was told that the total distance was 4,000 yards apart. I think it's very important to be able to draw a picture. A picture will be able to help you. And actually in the problem, it says to draw a picture. So they started at this point and then they walked in opposite directions until they were 4,000 yards apart. Alright, so from what we already talked about, we know that Amos's distance plus Eunice's distance is going to be 4,000 yards. Okay, I'm just going to drop my units for a minute. So Amos's distance is his rate times time. I'm going to keep those the label, the subscript of A, and then I know that Eunice's distance is a rate times time, and that equals 4,000 yards. So if I go back to my problem, so I can write down all the information that I'm told. So in the problem it says that Amos walked 240 yards a minute. Okay, when you're given yards a minute, feet per second, miles per hour, that's a rate. So that's Amos's rate. So I'm going to come over here and write all my information that I know about Amos. Alright, so we know that Amos's rate is 240 yards, and when you say a minute, that's like a fraction, yards per minute. So, and then it says Eunice left 2 minutes later, walking 200 yards a minute. We're going to come back to the time. So Eunice, the rate she walked was 200 yards a minute. So Eunice's rate is 200 yards a minute. One thing I always look at is, are all of my units matching up? Okay, I was given, my total distance was in yards. My rates are in yards per minute. My time, therefore, is going to be in minutes. So I'm going to leave everything in the units that it was given to me. I'm going to leave everything in yards and minutes. So, okay, so we want to know how long did Eunice walk. So we want to know Eunice's time. That's one of the things that we're looking for. And how far did they each walk? So we're looking for Eunice's distance, and we're looking for Amos's distance. Okay? So if we start with the fact that Amos's distance plus Eunice's distance, it equals 4,000 total yards. Okay? So then we can put in their rate times time. So if I can look at the things that I know Amos's rate, I know Eunice's rate, but then I still have these 2 unknowns. Since I only have 1 equation and 2 unknowns, I have to write another equation. If I have 2 unknowns, I have to have 2 equations. So I need to go back to the information that they told me about the time. They said in the time that it took, or that Eunice left 2 minutes later. If Eunice left 2 minutes later, you have to use some logic that Amos walked longer. So if Eunice left 2 minutes later, that means Amos walked longer. Eunice walked 2 minutes less. Okay? So I can write this time for Eunice, that the time for Eunice, she walked 2 minutes less than Amos. So we could take Amos's time and subtract 2. That would make Eunice's time smaller. Eunice's time should be smaller because she left 2 minutes later. So you kind of have to think about that when they tell you the time, okay? Now that we have another equation here, we can use substitution to solve. Because now that we have this, we have TE equals Eunice's time equals Amos's time minus 2. So we can use substitution to put in all this information. So we know the fact that Eunice's time is this, so we can take this and put it in here, right there. Okay, so let's just go to this formula. Let's go here and put in everything that we know. Okay, so Amos's rate, going to what we know, I have 240. Since I know all my units are going to work out, I'm just not going to write any of my units in for right now. Okay, so, and then I have Amos's time. I'm going to leave that plus Eunice's rate. Go over to my information. That was 200 yards a minute. And then Eunice's time, we're going to substitute this in for Eunice's time. So we're going to say TA minus 2 equals 4,000. So now we're down to where we only have one unknown and one equation, and that's a good thing. So this 200 has to be substituted. Solving this now just becomes algebra. Our unknown is the time, Amos's time. So we have 240 TA plus 200 TA minus 400, I'm distributing the 200, equals 4,000. These are the same kind, so I can combine them. 240 of these plus 200 of these is 440 of these. I can add my 400 to the other side. So I have 440 equals 4,400. Divide both sides by my 440. That goes away. Those zeros cancel. That should be 11 or 10. Yeah, just making sure. 10. And we're dealing with the time, Amos's time. And if we look at all of our units, everything was in yards and minutes. So therefore, this time should be in minutes. So Amos's time is in 10 minutes. The problem never asked us that, okay? The problem did ask us Eunice's time. So if Amos's time is 10 minutes and she left 2 minutes later, we can go back to this equation right here. We can put the 10 minutes in for Amos's time. So we know that Amos is 10 minutes, so Eunice is going to be 10 minus 2. So Eunice's time is 8 minutes. That was one piece of information that we needed. Now we need to know the distance of each one. How do we find the distance? Distance equals rate times time. Okay, so to find the distance of Amos, we can take his rate times his time. Well, the rate was given in the problem. His rate was 240 yards a minute. And then we just solved for his time, which was 10 minutes. So, just so you know, this would be yards per minute. This would be minutes. So therefore, our minutes cancel and we're only left with yards, which is a distance. So 240 times 10, 2,400 yards. So that's Amos's distance. So then we can find Eunice's distance because it's rate times time as well. The problem gave us her rate, which was 200 yards a minute, and then her time was 8 minutes. So Eunice's distance would be 1,600 yards. Okay, now our total yards was 4,000. These two numbers should equal 4,000 if you add these two distances together, and they do, because 2,400 plus 1600 is 4000. Okay, we're looking at 19C, 9 through 11. It says that two dogs took off. I mean, they have more in the word problem. Like there was an explosion and two dogs took off in the opposite direction. When they were 600 feet apart, they halted. Okay, so the fact, I'm just going to stop right there and draw me a picture. There was two dogs, and then they left in the opposite direction. And so I was told that the total distance, they stopped when they were 600 feet apart. So that's my total distance, okay? The dogs' names are Emmett and Princess. So we know we're going to have Emmett's distance, and then we're going to have Princess's distance. Okay, so we can already make the statement that Emmett's distance plus Princess's distance equals 600 feet. Well, we can replace Emmett's distance with his rate times time, and we can replace Princess's distance with her rate times time. So now let's go back to the problem so we can get more information about these two dogs. Okay, so going back to the problem, I'm going to write my information about Emmett, because then it says Emmett traveled 27 feet per second. Okay, so Emmett's rate is 27 feet per second because feet per second is a rate. And it says that he traveled for 10 seconds. So Emmett's time is 10 seconds. Okay, so now let's see what it says about Princess. Then it says Princess traveled faster. We don't know her rate, but we do know she went faster than 27 feet per second. So when you solve it, your number should be bigger than 27. And it says she traveled faster and longer by 1 second. That's a key word. That's why I underlined it. She traveled longer by 1 second. Well, if Emmett traveled for 10 seconds, Princess went longer by 1 second. So that means she went 11 seconds. Okay? So then the question says, how fast was Princess? Okay, so we don't know Princess's rate. That's one thing we're looking for. And then how far did each of them run? So we're looking for Emmett's distance, and we're looking for Princess's distance. So now let's go back to the formula that we wrote, and let's plug in what we know, okay? So I know Emmett's rate, I know Emmett's time, I know Princess's rate, I don't know her, I know Princess's time, but I don't know her rate. That will be the only thing that I don't know. So Emmett's rate, we said, was 27. Everything so far is in feet and seconds. So if everything is in feet and seconds, then I'm just going to drop my units for ease of solving the problem. But when I'm looking for, so everything, as long as I make sure that all my units are the same, then I'm good. Everything is in feet and seconds. So Emmett's rate is feet per second, 27 feet per second. His time is 10 seconds. Princess's rate, we don't know that, so we'll leave that as our unknown. And then her time is 11 seconds, equals 600. So this is my unknown, so I can multiply these out. So that'd be 270 plus, I'm just going to write this as 11 RP, because we normally see our coefficients in front. So now it's just a matter of getting our numbers together. Subtracting this over. So keep up with your letters because we're trying to find her Princess's rate. So 600 minus 270, 330, divide both sides by 11. So Princess's rate is 30, and we're dealing with the rate, and so our units for rate, feet per second. Remember, we said her rate should be faster than Emmett's, and his was 27. So this is a good thing that this came out like that. So that was one of the questions it asked. We should be finding 3 answers. How fast did Princess go, and what was the distance of each one of them? Okay, so for Emmett's distance, we can do his rate times time, because distance is rate times time. This information was given to us in the problem. His rate was 27, and his time was 10 seconds. And so his distance, when you multiply rate times time, you're going to get a distance, which is feet, 270 feet. That's Emmett's distance. So then we can find Princess's distance. That's her rate times time. We just solved for her rate, which was 30 feet per second. And then her time was 11 seconds. Told that in the problem. So her distance is going to be, split them and add them, 330. I don't think I did that right because that's times 10. Oh, yeah, I did. 330. Okay.